How would you solve a system of equations with three unknowns? You still have three methods: graphing, substitution, and elimination. You won't see graphing used in Algebra 2 because it deals with a three-dimensional object, and we don't graph three-dimensional objects in Algebra 2. However, we can still do elimination and substitution. So I'm going to kind of give you a generic way to solve this problem, and then tomorrow we'll get into a little bit more detail. But if you look at all three equations, notice that all the y's have the same or opposite coefficient. So one y is, or this term here is negative 3y, this term is a positive 3y, this term is a negative 3y. So this is the easiest that it's going to get. It's going to get a little bit more complicated than this, but you'll kind of get the idea. So what we're going to do, since we have three, we're actually going to break them up into pairs. So let's take the first two equations, and I'm going to rewrite them in red. So let's take x minus 3y plus 3z equals negative 4, and 2x plus 3y minus z equals 15. If we take these two equations and we add them together, and the reason that I'm going to add these two equations is because these two terms right here are opposite. So in order to eliminate the variable y, I would need to add in this case. Now when I add, remember this is an understood 1, so that would be 1x plus 2x, which is 3x. Negative 3y plus a positive 3y is 0, so we have eliminated the variable y for this equation. 3 plus negative 1 would be a positive 2z, so plus 2z. And negative 4 plus 15 would be 11. So now by adding those first two equations, we have eliminated the y term. Now let's take the last two equations, and I'm going to write these in blue. 2x plus 3y minus z equals 15, and 4x minus 3y minus z equals 19. Notice in these two equations, the y's are opposite coefficients again, so we will add these two equations in order to be able to eliminate the y variable. 2x plus 4x is 6x. 3 plus negative 3 is 0. We've eliminated the y variable. Negative 1z plus negative 1z would be negative 2z equals, and then 15 plus 9 would be 34. So now we're looking at two equations. 3x plus 2z equals 11. 6x minus 2z equals 34. If we use those two equations, they each only have an x and a z. So now we're dealing with two equations instead of three equations. So let's take those two equations. Let's rewrite those so we can see how we would solve that system. Now we're fortunate here, the z's have opposite coefficients. So in order to eliminate the z, we would need to add again. 6x plus 3x would be 9x. Negative 2 plus 2 is 0, so we've eliminated the z variable. 34 plus 11 would be 45. And then this is simple, 9x equals 45. If we divide by 9, we get x equals 5. Now this is only one answer. We still need to find out what y equals, and we still need to find out what z equals. But since we know that x equals 5, let's go back to this red and blue equation, choose either one of those. Let's choose the one in blue, and let's replace the letter x with the number 5. So that would be 6 times 5 minus 2z equals 34. that would be 30 minus 2z equals 34. If we subtract 30 from both sides of the equal sign, we're left with negative 2z equals 4. And then if we divide by negative 2, we get z equals negative 2. So now we know what x is, we know what z is. Well, I can't go back to these two equations anymore because I already know x and z. I still need to figure out what y is. So now we'll go back to one of those three original equations. It does not matter which one you go back to. We could use the first one, the second one, or the third one. But this time we'll replace the letter x with the number 5, and we'll replace the letter z with negative 2. So let's just say we go back to that very first equation up here just because it's written first. It doesn't really matter. You can use any equation. So instead of x, we would put in the number 5. Now it's going to be minus 3y. And instead of 3 times z, we're going to do 3 times negative 2 equals negative 4. So I've taken that first equation, plugged in what I know x is, now it's 5, and what I know z is, it's negative 2. And then just solve that equation. This would be 5 minus 3y minus 6 equals negative 4. We have some like terms here that we need to combine. So that would be negative 3y minus 1 equals negative 4. And when we add 1, I'm running out of room, so bear with me. When I add 1, that's going to be negative 3y equals negative 3. And then when we divide by negative 3, we get x equals positive 1. So we have three answers here. We have x equals 1. I'm sorry, this is y. We have y equals 1, x equals 5, and z equals negative 2. So when we write our solution, we're still going to write as an ordered pair, except it's not going to be a pair, it's going to be 3. We would write a 5. Then we would write our y, which is 1. And then we would write our z, which is negative 2. So there's our answer, 5, 1, negative 2. Now I'd like for you to do the best that you can to solve this system, 2x minus y plus z equals 4, x plus 3y minus z equals 11, and 4x plus y minus z equals 14.